Have you ever thought of using an invisible infrared light to build an invisible security barrier? Today we will weld an infrared alarm system based on the 555 timer. Its core is this classic 555 chip. It is configured as a monostable trigger, which is responsible for receiving the trigger signal and precisely output a fixed width pulse. To command the subsequent circuit to perform the alarm action, when welding, pay attention to the notch of the chip should be aligned with the C mark. Next, solder this BC547 NPN transistor. Its task is to amplify the weak signal from the sensor, ensuring that the subsequent circuit can respond reliably. Now solder a 1000 ohm resistor as a positive current limiting resistor for BC547, while protecting the transistor and stabilizing the input signal. This is the eye of the system. The photodiode.it works in reverse bias state. It is usually conducting when receiving infrared light. Once the light is blocked, the voltage changes immediately. The alarm is triggered. Solder another 1000 ohm resistor and the photodiode to form a voltage divider circuit. To accurately convert the light signal into a voltage signal and transmits it to the next stage. This 220 ohm resistor is the current limiting element, preventing the transmitter from being damaged by excessive current. Now install the infrared LED.it. Forms an infrared pair with the photodiode.it continuously emits an invisible beam. Normally, the light path is unobstructed. Once an object blocks it, the system responds immediately. Then solder a 330 ohm resistor as another current limiting element for the LED, ensuring the stable and reliable emission intensity. Next is a 10 kilo potentiometer. It is the sensitivity regulator of the system. By rotating it, you can precisely set the trigger threshold so that the alarm can respond to objects of different distances to respond appropriately. Solder this 0.01 F capacitor. It reduces high-frequency wave circuit noise, ensuring the detection signal of the photodiode is clean. This 150,000 ohm resistor together determine the width of the pulse output by the 555 timer, which determines the duration of the alarm. Solder another 0.01 F capacitor to the control voltage pin of the 555 timer to stabilize the working voltage of the internal converter to improve timing accuracy. This 2N4401 MPN transistor further amplifies the signal, ensuring that even weak light changes can reliably trigger the circuit. Without dead angles, solder a 10 kilo resistor to stabilize the positive potential of the transistor to prevent false triggering. This is a manual reset switch, which can reset the alarm state after pressing for system testing, or manually disarm the alarm after the alarm. Then solder a 1000 ohm resistor. It works with a button switch, ensuring the reset signal is smooth to avoid impact on the chip. This EF capacitor and the previous 150,000 ohm resistor forms an RC timing network to precisely control the output duration of the alarm signal. To ensure the duration of the audible and visual alarm, solder this 4,700 ohm resistor to limit the positive current of the driving transistor, ensuring the stable and reliable signal transmission. Now solder a 12-volt relay. When the alarm is triggered, it gets power to attract and control external loads. It is the key to realize the linkage of sound and light and perform security actions. This 2N4403 PMP transistor and the previous PAT tube form a complementary drive circuit, which greatly improves the driving capacity of the relay to ensure reliable suction. Then solder a 1000 ohm resistor as the positive bias of the 2N4403 to stabilize its working state. This diode N4007 is connected in parallel to the relay coil, is used to absorb the reverse-induced electromotive force. The reverse-induced electromotive force to protect the previous circuit. This is what we often call the indispensable protection element of the diode. Solder this 3000 ohm resistor to limit the working current of the buzzer to avoid overcurrent damage, the sound source of the alarm. When the alarm is triggered, it will make a sharp beeping sound. It serves as a warning and deterrent on site. Note that the positive and negative poles should not be reversed. Finally, connect a 12-volt light bulb controlled by a relay. When the alarm is triggered, the light bulb lights up, forming a dual alarm of sound and light with the buzzer. Especially in the dark, the effect is very obvious. The system is powered on. The infrared LED and photodiode align the circuit. Silence by blocking the infrared beam with your finger. The buzzer rings. The light turns on. Look, when the infrared beam continues to shine, the system is silent and guards. Once someone breaks in, the light is blocked. The alarm will be triggered immediately. Both sound and light will alarm. The effect is intuitive. Is the interesting combination of electronic technology.